Yeah, my name is Madhav PVL, and I'm pursuing my master's in business analytics at Arizona State University. And today I'm going to explain you about one of a Kaggle challenge, which is handling imbalanced data and ensemble predictions for home site insurance problem using SMOTE, stacking, and various other classification models. And today I'm going to explain about this problem in detail. So let's get started. So let's just see what is a problem statement. So basically here we can just see that the problem statement is nothing but usually there will be some quoting purpose for the insurance, like because the insurance plans differ from one person to another person. So that's the reason there will be some quoting happening over there. So the problem statement is we need to predict the customer whether he will just take the quoted insurance or not. Like, so that's the reason, that's the main problem statement. And then the challenges which I had faced with the data is it's very imbalanced data, because the minority and the majority classes are not in a proper range. So it's like the minority may be less or majority may be more or something like that. So there is a challenge with an imbalanced data. And so that's the reason our main objective is to use this mode for the imbalance of the class and some other techniques for a better accuracy. And then here we can just see, so in the data set the only one target variable which is quote conversion flag, it's one a number of the feature which are just seen in the data, and also there were no missing values in that particular feature, and appears to contain a range of numerical values instead of binary classification. So it's a range of numerical values in the sense more than two values, so that we can't just give a proper binary classification. And then here we can just see the target distribution. So this has a 68,000 change unique values, because of which the frequencies changes. So that's about the target. And then we can just see like the graph where, so this is before smote and this is after the smote. Like you can just see the minority classes are less and the majority are more, and then with the help of synthetic minority oversampling technique, which is smote, we had just performed some operations, and then we just balanced both minority and majority classes. So that's all about the handling imbalanced data with the help of smote. And then this is nothing but we can just derive some proper uh, data visibility, or we can just learn about new features, or we can just derive some meaningful expressions. Because if we just use smote, it's okay to just derive some proper conditions with the help of the data, only with the help of a smote. And then here we can just see these are the types of the models that I had used it for the prediction. And then I had used this many because to just compare in between, and like clubbing the whole thing at last. We'll just discuss that in the future slides. So MLP and support vector machines and decision tree, random forest and KNN. So these are the models which I had just used. And yeah, and here we can just see these are the these are the scores of this three models. And here we can just see the random forest, support vector machine, and KNN. So we had just developed this base models, and we can see the random forest has the highest accuracy. And then hyperparameter tuning is nothing but it's just finding the optimal solution out of a number of solutions. Like here this is finding out that this is the best solution to get the best accuracy from the random forest model. And for this one it's 80% for this KNN with the help of this hyperparameter. So hyperparameter will check for multiple perspectives where we can just get a perfect accuracy, the highest one. So that's about the hyperparameter tuning. And then we also use the grid search and random search. Grid search is also the same. It's just like searching for the number of possible outcomes for a proper accuracy. And then as I had talked before, the stacked model. So I had just used it all these things, and then we had created a stacked model. And here we can just see the highest among these are the random forest. The random forest has the highest accuracy, and the stacked model has just increased the accuracy of a random forest. So this is a result which I had just gained with the help of the stacked model. So that's the reason I had just checked out the performances of individual models, and then we had completed getting better accuracy with the help of a stacked model. So, yeah, so finally, while talking about the key takeaways, we can just say that SMOTE had handled the class imbalance perfectly, and then stacking is one of the essential method which made us get a better model performance, and then hyperparameter tuning is also helped us for an optimized result. And then the main reason of this thing, the coding thing, is nothing but here the data is very imbalanced. So that's the reason we need to use this kind of methods and models for getting a optimized result, to just predict whether the person will be able to take the insurance or not. And then yeah, so this is the importance of this project. And thank you for your time. Yeah, thank you.